Now that you've finished your test over chapter 10, now we're going to move on into statistics. So chapter 11 is the very last chapter that we're going to do in this class. So the first section that we want to talk about is the section on gathering and organizing data. So at the very beginning, we want to talk about the difference between populations and samples. So when you do a statistical study and you're interested in something, you usually begin with saying, I'm interested in the salary of all RNs in the United States, or I'm interested in how fast all of the roller coasters go in the United States. So you usually start with some kind of statement that you're trying to get information about. And if so, your population would be all roller coasters, all RNs, and in my example, all colleges in the United States. So that's your entire population. Most of the time, it's not feasible to gather data from every member in the population because it's just too big and there's no way you can travel to whatever 10,000 colleges or whatever it might be, or capture every salary of every RN in the United States. So we consider samples to be good representations of the population. So when we pull a sample, we want to try to be unbiased and we want to try to reflect the demographics of the population that we're trying to study. So that's why, like in the case of the US Census, we only do that once every 10 years because it's just so hard to find information about everybody that lives in the United States. So it's such a job to collect all of that information. We only do that every 10 years. Otherwise, on those other years, we pull samples to come up with unemployment rates or whatever it is that we're interested in. So we've got some different sampling methods. The first one is a random sample. So a random sample is like giving every element that's in your population a number, and you could think of it like putting it in a hat and drawing them. So you could put them in a hat and draw that number and say, oh, number 3, come with me to my sample. Number 72, come with me to my sample. So you could do something like that where you're drawing something out of a hat. Supposedly that's not necessarily random, that there's some things that happen when you're drawing things that maybe aren't random. So there's such a thing as random number generators, that you push a go button and it gives you, and it generates random numbers between 1 and 1,000 or 1 and 10,000, whatever it is you're looking for. And then that would be the way that when you get that number, then that member becomes part of your sample. And then you run the random sample generator again and you get your next item in your sample. And you keep running the random number generator until you get all 200 pieces of data or whatever it is that you're going to include in your sample. So random sample is the best way to collect a sample out of the population because everybody has an equally likely chance of being chosen when you're pulling a random sample. The second one is systematic sampling. So systematic is like a production line, or you could think of it like a turnstile, where every 5th person through the turnstile you pull over and ask a question. And then the next number 5 through the turnstile, you pull them over and ask a question. Same thing with something going down a manufacturing line. You would pull off every 10th item or every 7th item, and you'd pull it off and measure whatever it is that you're interested in your sample. So systematic sample is you take every 5th member, 12th member, 15th, whatever it might be, and you generate your sample that way. The next one is a stratified sample. So a stratified sample is where it makes sense to stratify your data in advance. So maybe we want to stratify it with something like freshman, sophomore, junior, and senior. So maybe we want to stratify it first, and we divide everybody up into those 4 groups, and then we would pull a random sample inside those groups. The reason somebody would do a stratified sample is that they would think maybe a freshman might give you a different answer than maybe a senior would, or or vice versa. Maybe a junior would give you a different answer than a senior. So that's why you might want to stratify something. You could stratify it also in terms of maybe age, because maybe in some kind of a medical condition you think age is important. So maybe you say less than 20, or maybe you say, well, between 20 and 40, and then maybe you go 40 and above. So maybe we go greater than 40. And so maybe we split them up because we don't want to mix them all in together, because we think we're going to mix the information and maybe skew our data. So we stratify it first, and then I would pick a random sample out of those people that are less than 20. I would pull a random sample out of the ones that are between 20 and 40, and I'd pull a random sample out of the ones that are 40 and older. So that's stratified sample. You stratify first, and then you pull a random sample. The next one is a cluster sample. So a cluster sample is something, and so let's draw an example. So let's say in the state of Colorado, just for grins, that we've got some kind of boundaries that maybe divide up our zip codes, let's say, something like that. So we're dividing these things up, and maybe they go like this. And we've got our zip codes all divided in the state of Colorado. And so that designates our cluster. So in my case of my drawing, we have 1, 2, 3, 4, 5, 6, 7, and 8. So maybe we have 8 clusters in the state of Colorado. Then what happens is you randomly draw clusters out of these 8. So that would be your next step, is you'd use a random number generator to choose maybe 3 numbers between 1 and 8. And let's say that when I pull those, I get number 3, and I get number 7, and I get number 4. So when I pull those random samples, let's say that that's the zip codes that I would pull. Now what happens is somebody would go out and they would survey everybody in this cluster, everybody in this cluster, everybody in this cluster. And so people like to do this because it saves money, because you can send 3 people out to like 3 different regions, and they can just go door to door and figure out what's going on in those regions, and you're not sending people out to all 8 clusters. Think about, like in the case of classrooms at Front Range, let's say that maybe we want to know how many people are left-handed, and so so the best way to do that would probably be a cluster sample, where we randomly pick classes out of the course schedule, and then we go to that class and we say, excuse me, can I interrupt your class? And you use that class as your cluster, and you survey everybody in the class. And so that way you're only interrupting one class at a time to get your information, and you're not going to every single class trying to pull a random sample. So when you do cluster sampling, you randomly sample first to get your cluster, and then you sample everything in the cluster. So here's an example. So in my example, I've got a student that's in an education class, and they're supposed to go and find out how late typical students at their campus stay up to study. So he decides to stop by the Commons area before his 9 a.m. class and ask everyone that he finds sitting at one table how late they were up studying the night before. So out of our methods that we did before, it's certainly not a random sample. We didn't stratify it, so he didn't take it and stratify it by class or by degree or anything like that, or even by time. And it's not a systematic sample because he didn't talk to every fifth person that walked by him. So this is an example of a cluster sample because he went to one table. So you can say that was his randomly selecting a table. So he went to one table and he talked to everybody that was sitting around that table. So I asked in the second part, I said, do you think that he's likely to get a good representation of everybody that goes to his college? And the answer would be no, right? Because the people that are sitting at that table, number one, they're sitting at the table before 9 a.m. So they're a certain type of student. So it's not representative of the evening student or anything else. He's also talking to a table that probably those people that are at that table are friends and they have similar beliefs, or maybe they have the same major or they're in the same class, so they would have similar opinions. And so it's not a good representative sample of every student that goes to Front Range Community College. Next thing we want to talk about is descriptive versus inferential. So there's two different branches of statistics. The first one is descriptive. So that's where you're just going to collect your data, you're going to organize it, and you're going to report on that data and talk to people about what you found. So in my example, a researcher might be interested in the average age of the full-time students on your campus and how many credit hours they're scheduled for the term. So they're just kind of reporting out from what they found in their statistical experiment. The second one is inferential. So this is studying characteristics of a sample that's part of a population, and then you're drawing conclusions about the entire population based on that. So my example says the Bureau of Labor and Statistics estimates the number of people in the U.S. that are unemployed every month. Since it's impossible to survey everyone, you pick a sample and then you use this information to estimate the unemployment rate for your whole population. Another area of inferential is called hypothesis testing. And so a researcher would decide on something like, does taking vitamin C prevent colds? So they're looking for the fact that is there enough evidence that that would be true or not. The last inferential idea is correlation and regression. So we want to see if there's a relationship between two different variables. So for instance, in my example, is caffeine related to heart trouble? So you'd look at that correlation between those two things. So next thing that we want to talk about, so we'll probably talk a little bit for the next 2 minutes and then we'll pick it up on the next video, is we want to talk about a frequency distribution. So this is the way that I can collect my data. So I've got a pile of data and I'm trying to make sense of it and I'm trying to present it. So the data collected for this study that I'm doing, whatever it might be, is called raw data. And so we're going to talk about the two methods that we're going to use to organize the data. So we're going to organize it with frequency distributions. So we're going to talk about the categorical frequency distribution and the grouped frequency distribution. And then we're going to talk about something called a stem and leaf plot. So we're going to stop here and then I'll continue on in the next 15-minute video and we'll talk about these last three things, the two distributions and the box and the stem and leaf plot.